Did.
Hi, my name is Ann Scanello, and I'm one of the tutors with the Seeds of Literacy program. Tonight's math lesson is going to be actually just a GED practice test that I found online. The test that I located did have some answer feedback, but the feedback explanation was so poor, I thought it would probably be worth our time to fully work through some of these problems. So I put the website for the practice test up on the screen. Don't feel like you need to log into that right now. My suggestion would be work through the test with me tonight, give it a few days, and then go log on to that site on your own and see if you really remember and are able to answer all those types of questions. Okay, so let's get started. Our learning goals tonight. I want to get familiar with the GED Formula Page. I know not everyone is taking the GED, but any other testing you might have to take, frequently there's going to be a formula page given. Get familiar with the online calculator that is provided for the GED. And then I actually want to work through 10 GED practice math questions. Okay, first of all, the formula page has got a lot of subjects covered. They talk about the area and the perimeter of different shapes, surface area and volume. They've got some data formulas, the mean and the median formulas. Algebra, there are several algebra formulas. And then in addition to that, there's an online calculator provided on the GED. It's a pretty standard calculator. Unfortunately, it's not the exact calculator I have tonight. In my experience, calculator error can cause a lot of problems for students. Students that understand how to work the problem have a missed keystroke on their calculator, or they don't know all the different ways they can use their calculator. So I want to be talking about that some tonight too. So for instance, on this calculator, you'll see that there are numbers and letters on all the keys like you're used to. But above in yellow, you can see that there is a second function provided by that key. And we're going to work some problems using these second functions. But anytime you wanted to use one of these functions in yellow, like for instance, here's a percent sign. If you wanted to put in 8%, which I think we're going to have to do in this lesson today, you would punch in the number 8 and then the second yellow second button, and then you would press this parentheses, but it would do percent, and it would actually put 8% into your calculator for you. Okay, on the practice test that I gave you the website for, there are lots of reference sheets, and you can work through these on your own. I just wanted to point out a couple of things while we're here. Basic math, I think most of us can use a calculator. One thing I wanted to make sure I pointed out, though, they were punching in 8 times by -4 plus 7. So many students, let me get my pointer going. So many students want to use the subtraction sign for negative, and that many times will give you an error message. The negative sign is at the bottom left. There it is. I circled it in green of the enter. Whenever you're inputting a negative number, make sure you use the negative sign, not subtraction. Percentages, this is the one I just talked about. If you want to put in 40%, you type in 40, second function, and that percent, and it puts 40% in your calculator. What is the scientific notation? There's buttons for that. It's right there. I've circled it on the calculator. Oh, when you're using scientific notation or fractions, you're going to have to use these buttons that I've circled in red to advance your screen. So we'll see that in action in a little bit. Fractions, multiplying fractions. You can see you've got the fraction button that you can use. Not in yellow, it's the first function. You'll have to use those advanced keys. We've got mixed numbers. So the mixed number is actually the second function of the fraction key. We have got powers and roots on those buttons. And then we've got the toggle key. This is another one that it was a long time before I realized how to find it. The toggle key is circled in purple right down here, and it's got two arrows on it pointing either direction. That will take you back. Clicking that button will take you between having a calculator having a fraction showing on your calculator and having a decimal. So if you're given an answer in decimal form, but you need it in a fraction, you click that toggle button. Or just the opposite. If you're given the answer in fraction and you want it as a decimal, you click this purple button and it will switch your answer back and forth. Okay, two things, the two most frustrating things about the calculator, the most common errors that I see students using. Do not use the subtraction sign for a negative number. Make sure you use the negative sign and that toggle button. If your answer is in a fraction and you want it as a decimal, you can use that toggle button to get it there. Okay, so now let's go ahead and get started. So our first question, so I've got a student today, I've got Danielle. Danielle, I am going to read the question out loud, and then if you'd like, I'll give you a minute to work it, and then after you've finished working it, we can compare answers. Does that sound okay? Are you okay with that format? Are you there, Danielle?
Your sound is real low.
Is it? Okay, you want to know what? Last week, I'm going to dial in.
You said last week, what happened?
Well, last week, my volume wasn't working at all. I thought I had it fixed, but I did learn how to dial in on my phone, and I think that will fix our problem. So let me do that.
But I do have that screen up on my laptop. I'm on my phone because that's the only way I can download that app. I can't download stuff on my laptop for some reason. It keeps making me log in and out of my Microsoft store.
Oh, that is annoying. 701 pound. Okay, 1 pound.
Okay, Danielle, are you there?
Yes.
Okay, can you hear me better? Is that better?
Yeah, I can hear you.
Okay, good. Okay, this is what I've had to do the last 2 weeks. I don't know what's wrong. See it, it's my computer. I don't know what's causing the problem, but okay. So I'm going to go ahead and read the question out loud, and then I'm going to have you solve it, and then you and I will compare answers. Okay? And if there's one that you don't know how to work or you don't want to solve it, you can just say, Ann, you go ahead and do it. So the question says, and I've got to move all this stuff out of my screen. It says, a painter rented a wallpaper steamer at 9 a.m. and returned it at 4 p.m. He paid a total of $28.84. What was the rental cost per hour? Are you good with that? You go ahead and try to solve that one, and then we'll compare strategies.
Hello?
Oh, hello. Are you solving that question? Did you solve it yet? Or do you just want me to solve it? See, I think now I can't hear you is the problem.
Hello?
Can you hear me, Danielle?
Yeah, I
Yeah, I
forgot
couldn't.
that it's raining. I forgot that it was raining too.
Oh, does that make the reception bad?
So it's like it's the connection. That's what's messing up the volume. It's taking the
Okay.
audio out.
Because it keeps, I can see where it says that you're talking, but I can't hear you. Okay, well, I'm going to go ahead and work through the problems then. It might be easier just to do that. I don't know if the recording would work for later on or not. Okay, it said a painter rented a wallpaper steamer at 9 a.m. and returned it at 4 p.m. He paid a total of $28.84. What was the rental cost per hour? The first thing you have to do is figure out how many hours did he actually have it. From 9 a.m. to 4 p.m., 7 hours. And I just count that on my fingers. You know that he paid a total of $28.84. So we just need to divide by 7. And our answer is $4.12. And that's it. Okay, number 2 is a little more challenging. It says, what is the value of 36x minus 8y squared? And they're telling us that x is equal to 3 and y is equal to negative 6. So Danielle, I'm going to pause for about 20 seconds. If you're watching the video, you could pause the video on your own, and then I'll start to explain it. Okay, in order to solve this problem, I rewrote the equation, 36x minus 8y squared, x equals 3, y equals negative 6. We just have to substitute the values for x and y into the equation. So right where there was an x, I put parentheses to remind myself that I'm multiplying 36 times by that value of x. And then again, where the y is, I put parentheses to substitute in negative 6. At this point, you could use your arithmetic skills to solve this problem. But this is a really typical example of where I've got students who know how to do all of the math correctly, but they make a mistake. They hit a wrong key, and they wind up getting the wrong answer. I also will say some questions on the GED, they're going to offer a calculator, and others they will not. I get students all the time at Seeds who are like, nope, I want to work them all out the long way to practice. I'm going to encourage you on the GED, it's a time test. And even I've been teaching math for a long time, even I had to be aware of my time. So using a calculator when they allow you is a great idea. Okay, so, and I'm hoping that you can sort of see this. Okay, so here's my calculator. It's not exactly the one they provide, but it's very similar. So I am just going to type in exactly what I have on the screen. So I am going to type in, I'm going to do it so I can see it, 36, and then open parentheses, 3, close parentheses, minus, I'm going to put an 8, open parentheses, negative 6, close parentheses, and then I'm going to use my square root button. Oops. Can you see it? Right there, and I'm going to make it squared. Okay, let me make sure it all came in. So let me show you. Hopefully you can see that line. If you can type that exact sequence into your calculator, the calculator already knows the order of operations. It knows how to solve that. So all we have to do is press enter to get our answer of negative 180. There are so many ways to make a mistake doing that math the long way, and the calculator makes it so much more simple. Question number 3. Annie is planning a business meeting for her company. She has a budget of $1,325 for renting a meeting room at a local hotel and for providing lunch. She expects 26 people to attend the meeting. The cost of renting the meeting room is $270. Which inequality shows how to find the amount X that Annie can spend on lunch for each person? This is a really good example of a real-world type problem, something that you might have to solve in the future. It's very confusing, and I know a lot of students are just intimidated by the difficulty level. So go ahead and take a minute, see if you can solve it, pause the video, and when you turn it back on, I'll work through it. Okay, unpause. The first thing I want to show you is remember that formula page. For algebra, they give you a number of formulas, and one of them is called the slope-intercept form of the equation of a line. It is for any linear equation, you can use this y equals mx plus b. In my experience, several questions will be using this equation. That's why I like to do a lot of practice with it. So, slope-intercept form, y equals mx plus b. I've done several lessons on this subject that you could go back and watch the videos, but here's another one. In the position for y, that's where your dependent variable is going to be. For our purposes, we're just going to leave the letter y there. In the position where we have the m, we're going to have to substitute in our slope. Now, sometimes they'll tell you the slope is so-and-so, but sometimes they'll use words like unit rate or constant of proportionality or coefficient of x. But regardless, in order to have a linear equation, we're going to have a number in this position where it says m. Our x is going to be our independent variable. When we write a linear equation, our y is going to stay a y and our x is going to stay an x. B, in this position, we're going to substitute a number, and it's going to be our y-intercept for the problem. If you're working a word problem, the y-intercept, you'll be able to figure out what that is because it will be the beginning amount of what you're doing. Sometimes they might call it starting point. If you're looking at a table, it will be the value of y when x equals 0. At this point, I would highly recommend, if you haven't copied down this note page, to copy it down, take a screenshot. This is information you need to have memorized before you walk in to take the test. It will not be given on the formula page. Okay, so back to our problem here. She's planning a business meeting for her company. She has a budget of $1,325 for renting a meeting room and providing lunch. She expects 26 people to attend. The cost of renting the meeting room is $270. Which inequality? Okay, so our budget was $1,325, 26 people, room cost $270. And our slope-intercept form of the linear equation, y equals mx plus b. So I said that we're going to leave the y and the x exactly as they are. The number of people, that's going to be our independent variable. We have to multiply the number of people times by the cost of lunch. So the more people you have, the more you're going to spend on lunch. The fewer people you have, the less you're going to spend on lunch. You're going to have to multiply number of people by price of lunch. So it's going to be 26x. And then for our y-intercept, that's where I substituted our room cost. I did that because when we're figuring out our expenses for this meeting, before a single person attends, our starting point, or the beginning amount of money we're going to have to pay, is $270 for the room cost. So that number has to be added on to the cost of lunch multiplied by our number of people. So we have our equation, y equals 26x plus 270. Oh, but wait a second. That's not an option. That's none of our choices. Okay. So they have told us our total budget is $1,325. That is going to be our dependent variable. You know, the total amount that we spend depends on all the costs we have over here on the right side. So I am now going to substitute 1,325 for y. Now also, they have an inequality, and mine, I have an equal sign. So let me see if I wrote it. I did. Good. So I substituted my total budget, total amount of money I'm allowed to spend for my dependent variable right here. So now we just have to ask ourselves, so the right side of the equation is the amount of money so our total cost that we're going to have to pay. And the left side of my equation is the total amount of money we have. So we ask ourselves, do we want to keep our costs less than our budget, or do we want our costs to be more than our budget? When you look at this inequality sign, you know that the smaller side needs to be pointing to the smaller value. So our costs need to be either smaller or equal to $1,325. So this, my statement would be read, $1,325 is greater than or equal to 26x plus 270. They wrote it a different way. They put the cost first. So they put their 26x plus 270. They put that first. And we have a choice. Do we want the cost to be on the larger side of the inequality sign and then the budget on the other side? Or do we want our costs to be on the smaller side? Do we want our costs to be less than $1,325? We want the cost to be less than. So the cost side is close to the small side of the equation. You see over here on mine, the cost figures are on the small side of the inequality sign. It's easy to get that mixed up, but just pay attention to detail and you'll be okay. So B is the correct answer. Dominique earns $285 per week plus 8% commission rate on all of his sales. If Dominique sells $4,213 worth of merchandise in 1 week, how much will his total earnings for the week be? So I'll give you just a minute to work through that one. You can pause the video and then you can turn it back on. And I will work through it. Okay, so we know that Dominique's salary is basically $285 per week, plus he gets 8% commission rate on all of his sales. So basically, he gets 8% of all of his sales. I don't know if you've taken any lessons on word problems. The word of, if you can restate a problem using the word of, it virtually always means multiply. So 8% of his sales would be 8% times by his sales. So there's two ways to work with this one. I mean, as a student, I learned and I used to teach that 8% is the same thing as 0.08. And so we could just put our equation into our calculator, rewriting 8% as 0.08. But we were talking about how to use our calculator to our benefit. And I can't tell you how many students I have miswrite that 8% as 0.8 instead of 0.08. So I want to try to show on the calculator. Up here so I can see what you're looking at. Okay, so I'm going to hit my 285. That's pretty easy to do. My plus sign. I'm going to put in 8, and now I'm pointing to the percent. And the percent is on that key. So I don't have to press my second button, but I press percent sign and it says 8%. Now I'm pressing my open parentheses and I'm putting in 4,213 and then I'm hitting close parentheses. So look at my screen. Make sure that it's correct. Good. My screen says exactly the equation that I have on my computer. 285 plus 8% times by, or open parentheses, 4,213 close parentheses. Now I press equals, and the answer, where's it at? $622.04. And that is one of our options, always good. So we select D. Number 5 is a really long problem. So there's just a lot of information about these trees that we have to keep track of. So I'm going to read through the initial problem first. It says, a scientist is studying red maple tree growth in a state park. She measured the trunk diameters of a sample of trees in the same month every other year. The table shows the data for 2 of these trees. So we've got information on tree 1, got information on tree 2. She just did the measuring on odd number years. So year 1, 3, 5, 7, 9, and it goes all the way through for both of these trees. And then we've got the diameter of their trunks. Okay, this is the final year in which she will collect data. When her data collection is complete, she will predict future red maple tree growth. So the scientist plots the data for tree 2 on a coordinate grid. She begins by plotting data for year 3 and year 11. What are the locations of the 2 points on the coordinated grid? And then they give you directions. Click on the grid to plot the points. I'm not using their grid, so mine will be a little bit different. First of all, we need to pay close attention. We're only talking about tree 2, so we're only going to be looking at data for tree 2. And also, we are only interested in year 3, which is circled, the data is circled in green, and year 11, the data is circled in blue. So they gave us a lot of information, but we have to make sure that we're zeroing in on the correct information. Okay, so here's our coordinate grid where we need to plot it. So we need to plot these 2 points. So year is our X value. When we've got a table, there's always going to be, or typically, there's going to be 2 columns or 2 rows. The first one is always going to be your X value. The second one is always going to be your Y value. It's always alphabetical order. So our year is going to be on the X axis. You can see this little X down here. Year is on the X axis, so we're going to have to find the number 3 on the X axis. And the Y axis is going to be our trunk diameter. You can see the Y up here. So they have our diameter in inches on the Y axis. Okay, so the first thing we need to plot is year 3, the diameter was 12 inches. So I start at the origin when I'm plotting. I go over to year 3. I go up to 12 inches. I'm very careful to stay lined up. And I'm going to click. And there is my first point. Now I need to plot the point 11 years and 14.4 inches. So I'm going to go to 11. Be very careful to travel in a straight line. And I need 14.4. In the explanation for this one, they made the point that they intentionally wanted you to find something between 2 whole numbers. So I'm a little above 14, but I'm not quite halfway to 15. I mean, I'm really close to halfway, but not quite. And I'm going to click. and there is my second point. Okay, that's it. We've plotted those 2 points, and that's the correct answer. Okay, we're still talking about the trees, but this question is a little different. And it's going to be worth 2 points. All of the questions on today's practice test were all worth 1 point, except for this one is worth 2 points. In this one, when we have our final answer, we're going to have to, if you were on your computer, you're going to have to drag your choice of these numbers and letters up to the correct boxes. So you're going to have to drag 3 of these squares, 3 of these values, in order to get a total of 2 points. So it says, the scientist creates an equation that models her data for each tree so that she can predict the diameter in the future. Complete a linear equation that fits the data for tree 1, where X is the year and Y is the trunk diameter in inches. Click on the variables and number you want to select and drag them to the boxes. Okay, so this time we are only looking at the data for tree 1. And again, we're talking about equations, and they're telling us it's going to be a linear equation for tree 1. So if you remember linear equations on our GED Formula Page, we have the slope-intercept form of the equation of the line. I used to call it the standard equation of a line. Y equals mx plus b. We worked with this one just a minute ago. We're going to work with it again. Okay, so that's basically what our equation is going to look like. Here's that note page again. So our y is our dependent variable. Our m is called the slope. Sometimes you hear it called the unit rate, constant proportionality coefficient of x. Our x is going to stay an x, and that's our independent variable. And our b in this position is where we're going to put our y-intercept, which is also called the beginning amount, the starting point, the value of y when x equals 0. So again, take a screenshot of this or copy this down. These are good notes that you need to have memorized walking in the door. Now here are some more notes. I'm going to work through them quickly. There are several videos that I've done that include these that explain all of the different details. But slope with a word problem is found one way. On a table, it's found another way. On a graph, it's found another way. And in an equation, it's found another way. This is another page. Take a screenshot or copy down these notes. You will need all of this information memorized walking in the door. Take a screenshot. Y-intercept. Word problem. Here's your strategy. If you've got a table of values, here's your strategy to find the y-intercept. If you have a graph, here's your strategy. If you have an equation, here's your strategy. Again, done several videos reviewing this in more detail, but right now, take a screenshot of this or copy it down. Information you need to have memorized. And now let's use that to help us solve this problem. Okay, scientist creates an equation that models her data so she can predict the diameter in the future. Complete a linear equation that fits the data for tree 1, where x is the year and y is the trunk diameter in inches. Okay, well, we know that linear equations look something like y equals mx plus b. We also know that we're going to leave the y just exactly the way it is, but we need to substitute a number where we have the letter m. And that number, if you'll remember from our note page, and I copied that part of it, that number is called the slope. So this green position is where we put our slope. Now, we have a table of values. So we're going to have to calculate the slope by looking at this table. So remember it said on my note page, it said when you have a table, to get the slope, you're going to find the change in y and divide that by the change in x. Okay, So remember, we said year was our x's, diameter in inches is our y. So we need to look at how those values are changing. And so the change in y, so on our y side, it looks like the value is going up by 0.6. So the change would be plus or positive 0.6. The x side is changing by 2, because remember, she measured every other year. So we would have to write the change in y, which was plus 0.6, over or divided by the change in x, which was 2. So 0.6 over 2. If we simplify that, it's going to equal 0.3. So up here in our linear equation, the position that says M, we're going to put 0.3 in that exact spot. But wait, we're not done. We have to plus B. And if you'll remember, we said in this position where it says B, that's where we're going to insert our y-intercept. Hopefully you have a copy of that note page about the y-intercept, but I took off the part of that note page that's talking about how to find the y-intercept from a table of values. Now, this is a pretty tricky question because it says when you have a table of values like we do, we need to look at the value of y when x equals 0. Here's the thing. Many times they will have where x equals 0 and you just look right next to it and that's your y-intercept. But not always. Sometimes they leave out where x equals 0 and we have to figure it out. So this is where it gets a little bit tricky. Every year we figured out that trunk diameter gets 0.3 inches bigger. Now on our table, it jumps up 0.6 every time because that's for 2 years. But every 1 year, it gets 0.3 bigger. So if we were to put 0 onto our table, so we could use it to find our y-intercept, if we had 0 on there, we know that the trunk diameter would have been 0.3 smaller. It would have been 18.3, so that 1 year later, it would have been 18.6. 1 year later, it would have been 18.9, but she chose not to include that. Okay. If you can understand how I did this, and this is how I would consider a very tricky question, now all you have to do to find your y-intercept is look at where x equals 0, and this number, 18.3, that's our y-intercept. It means we're going to substitute it for B in our equation. So it looks something like this. Okay, so we're writing it over here. So now I'm clicking and I'm dragging their values down here. We know that y, we left y. Our slope, or our m, was 0.3. So I drug the 0.3 up there. The next thing is going to be the x. So the x goes right next to it. And now we're going to add the y-intercept. And we just figured out the y-intercept was 18.3. And so that was a pretty tricky question. I think most students could figure out the 0.3x part. 18.3 is going to be a little more of a struggle. My guess is that's why it's worth 2 points. So you could at least get 1 point for calculating the slope. Okay, we are still looking at this tree. Question number 7. In year 13, the scientists will put tree wrap around tree 1 to protect it from the winter snow. The height of the tree wrap needs to be 45 inches. The wrap is priced by the square foot. To the nearest square foot, how many square feet of wrap does she need? Okay, there is a lot going on in this problem. First of all, this tree wrap that's wrapped around the tree, you have to imagine that if you were to cut that open and flatten it out, that it's going to be where are we at? Rectangular. And I also forgot to note, we're only looking at the data for tree 1 right now. So I circled tree 1. So don't look at tree 2 anymore. We're just looking at tree 1. If we were to cut open the screen mesh, flatten it out, it would be a rectangle. And our job is to figure out how many square feet of wrap do we need to go by. Okay, so we know our rectangle is going to be 45 inches tall because she told us that. She said that it all needs to be 45 inches tall. But the distance around the tree, you can imagine that it's a circle. That cylinder that kind of goes over the tree has a circle at the top. So when we open the wrap, the distance of this width or the base is going to be the same distance as the distance around the tree. And that is called the circumference. That's something else. You have to kind of go into it, understanding some vocabulary and knowing that the distance around the circle at the top of the cylinder is going to be a circumference. Okay, so back to our math formula sheet. We're going to need a couple of formulas. One of them is for the rectangle. We're going to need the area, and that's going to be length times by width. Sometimes you'll hear people say base times by height. It's the same thing. The two numbers on the rectangle get multiplied together. For the circumference, distance around a circle, sometimes you'll hear people say perimeter of a circle, but the proper term is circumference. There are two different formulas. In our problem, we're going to use, so it's C equals 2 pi r, or you can use C equals pi d. We're going to use C, or circumference equals pi d, because they've given us the diameter on the chart. And for pi, there's lots of lessons on pi too. They're telling us we can go ahead and use the approximate value of 3.14. So these are the formulas we'll need. So let's see here. We need to figure out the circumference in year 13. And what we know is that 22.2 is our diameter that year. So circumference, they told us, was equal to pi d. So now we're going to substitute 22.2 right there where it says d. And honestly, I don't think I did it. Did I? Nope. I should have written in 3.14 where it has the symbol for pi. I just wasn't thinking to do that. In a situation like a standardized test, they're almost always going to want you to use 3.14 as your approximation of pi. Other times they'll want you to use exact pi, and that's on your calculator, but we're not going to do that. So I'm going to type in, instead of pi, 3.14, open parentheses, 22.2, close parentheses, and I'm going to hold that up to the screen and hope that you can see that that is exactly what I typed in. I'm going to press enter and let the calculator do the work for me, and the answer is 69.708. I rounded mine. So we need to use that. So this distance across the top of our rectangle is 69.74 inches. And the area of the whole rectangle, which represents the green wrap that goes around the tree, we're going to have to multiply these two numbers, 45 times by 69.74. I'm going to use my calculator. 3,138.45. Okay. Now, we're not quite done because the issue is that's not one of our choices over here. The problem is that our answer is in square inches. And they've asked us to put our answer in square feet. So I drew a picture of a square foot, and it's 12 inches by 12 inches for a total of 144 inches. So we need to divide our answer by 144 to come up with the answer of 21.79 feet squared. Now we look at our options, and 21.79, it says rounded to the nearest foot, rounds up to 22, so our answer would be A. Okay, we've got time. Question number 8. They took it a little easier on us with this one. The graph shows the level of ibuprofen, Y units, in a patient's bloodstream X hours after the ibuprofen was taken. So they've got the level of ibuprofen in a patient's bloodstream increased from, and they've got a selection box, hours, to another selection box, hours. So here's our chart, ibuprofen levels in a patient's bloodstream, time since ibuprofen was taken in hours, so the amount of time that has passed, and the ibuprofen level, the units that you have in your system. So they want us to say the level of the patient's bloodstream, in the patient's bloodstream, increased from what amount to, from what number of hours to what number of hours. Okay, so the first selection box, these are our choices for the number of hours. Second selection box, these are our choices for the number of hours. Okay, on your chart here, we have to find where the graph was actually increasing. And there's only one point where it was, and it was right here at the beginning. So the increase starts at 0 hours, and it continues, and actually, it's not even 1 hour has passed when the increase stops, and it starts slowly going down again. So we are less than 1 hour. And we can see our options over here. 2/3 is the only option we have of less than 1 hour, and that looks like it's about 2/3 of an hour. So 2/3. Okay. An office uses paper drinking cups in the shape of a cone with the dimensions as shown. So they're moving us on to some geometry. To the nearest tenth of a cubic inch, what is the volume of each drinking cup? So they're telling us the diameter is 2 3/4 inches across, and it's 4 inches tall. Here is our formula page, and it tells us the volume of a cone is going to be 1/3 pi times r squared h. So I cut off that part of our formula page so we'd have it. So let's go ahead and start inserting. So we know that our formula is 1/3 pi r squared times by h. So we need to start substituting. So 1/3, got that. For pi, we need to substitute 3.14. R stands for radius. And here's the problem. They didn't tell us the radius. They only told us the diameter. So again, you're responsible for knowing some of the vocabulary. Again, I did some lessons a couple of months ago, on vocabulary. Here is one of the diagrams I used in that lesson. Here's a circle. The diameter is marked in red. It's the distance all the way across the circle. The radius is half of that distance. It's marked in green. It goes from the center of the circle out to the edge. So it is half of the diameter. So the first thing we need to do is calculate half of 2 3/4 inches. So this is another one of those times I wanted to use my handy dandy calculator. And there is a fraction button, a mixed number button. And let me show you. It's right there if you can see it. It says U, and then next to it is N/D. I'm going to push that button because now it's going to allow me to put a mixed number in. I'm going to punch in 2, and it looks just like that. The thing is, can't see it very well. I'm going to have to use this advance, the big blue button on the side, to advance me to be able to write on the top of the fraction. So that would be a 3. And now I'm going to press the blue button down to type on the bottom, and I'm going to put 4. I'm going to have to advance to the right. And now I'm going to do divided by 2 equals. And so my answer is 1 3/8. But you know what? I really prefer to work with decimals. It can be easier not to use all those keys I'm not familiar with. So this is a time when I can use my toggle button. Where's it at? Toggle button is, there it is right there with the 2 arrows. And I'm going to press my toggle button to turn it into a decimal of 1.375. Okay, so now let's start doing some substituting. 1/3 is 1/3. Pi, I'm putting in 3.14. My radius, I turned it into a decimal, 1.375, squared it, and my height was 4. I can type all of that into my calculator. The special buttons you're going to need, this is the one you actually get with the GED, are the fraction button for 1/3. You're going to need the squared button to square 1.375. You're also going to need the parentheses. Didn't show those. And your answer is volume equals 7.92 inches cubed. They don't have 7.92, but they do have 7.9. The nearest tenth. And I think that's all the time that we have today. So we'll do the next question next week. Thank you very much for your time, and have a great week.